All right, similar figures. Similar figures is an important topic, but also a pretty easy one. It's important because we use the idea of similar figures to prove a lot of things in maths. What are similar figures? They have the same general shape, but are of different size. So the angles will be equal and the proportions of sides will be the same, but they won't be the same size. So it's basically when you enlarge something or reduce something, and you guys have seen that a million times whenever you resize anything on your computer, you know exactly how that works, keeping everything in proportion to each other, but just enlarging or shrinking. Symbols for similarity: 3 vertical lines. We had 3 horizontal for congruent, 3 vertical for similarity, or just a tilde, a little squiggle, which is the lazy man's option, and I'd probably do that more often than not. A couple of quick examples are all you're going to need. Write a similarity statement for these 2 shapes. Now you've got to be careful again with the labeling, so I'm going to go the longest one. Oh no, I guess I'll go alphabetically for the first one. Why not that way? So I'm going to go A, B, C, D is similar to, and now to get the same long part of the bottom than the short bit, I'm going to have to go E, F, G, H. So A, B, C, D is similar to E, F, G, H. That's all you got to do. Complete the following. EF over something is congruent to, or is equal to, something over CD. Well, what corresponds to CD? GH. So they're going to have to EF over GH. And what was the corresponding side to EF? That would be AB. So the proportions, if I take side length EF and divide it by GH, that'll be the same as AB divided by CD. Find the scale factor. Well, we've got 2 corresponding sides that we know. We know the 12 and the 16 correspond. Now the original length I'm going to call ABCD and the other one 12. So for the scale factor, the other one, the 16 will be the image length. So 16 divided by 12. So I get a scale factor of 4 over 3. Find the value of x. Well, to find x, it corresponds to the 9. So if I'm doing part D, x would equal the scale factor, 4 over 3, times 9. Therefore, x would equal 12. And these are in meters, so let's include our units and find the value of y. Part E, I'll just use whatever space I've got available. Y would be equal, or y multiplied by 4 over 3 should end up equaling, so if I take this side, AB, which is labelled y, multiply it by 4 over 3, I get the corresponding side of 14. Therefore, y equals 14 divided by 4/3 is the same as 14 times 3/4. Y would equal, 4 goes into that, 2 goes into that twice, and into that 7 times, 21 over 2 meters, or 10.5 meters if you'd rather. Not too bad there. Second question we've got is a BMX ramp has 2 vertical supports as shown. You can see them in the diagram there, brilliantly illustrated, or there they are again over here. Find the scale factor for the 2 triangles. Some people may have trouble even seeing the 2 triangles. There's a small triangle there, and the larger triangle which goes around the outside. Now if I was given this, I would probably draw them separately. So this one is 1 meter and something we don't know, and this one's 1.6 meters by 1 meter, and they're both going to be right angled triangles. And from there, so to find the scale factor, well, scale factor equals the image length divided by the original, so 1.6 divided by 1, the scale factor is 1.6. That was pretty easy. Find the length of the inner support. Well, if I take x and I multiply it by 1.6, I obtain 1. So x would be 1 divided by 1.6. This is why I don't like decimals, and I will use fractions. 1.6 is 16 over 10, or 8 over 5. So 1 divided by 8/5 is the same as 1 multiplied by 5/8. So x would equal 5/8 of a meter, which for those of you who really have a problem with that, you could write 0.625 meters. It's that easy. get stuck into them. You should be able to race through this exercise and the next couple. They're all pretty short and pretty straightforward. Good luck.